Let's find the equation of quadratic graphs by looking at the axis of symmetry. Okay, so if we're given a question and it asks us to find the equation of a quadratic graph, but it doesn't give me all the intercepts, then we can still work on it by looking at the axis of symmetry. Okay, so let's take a look at this question that we have. Okay, well, let's see what we have in this graph so far. Well, it tells us that there's an intercept at x is equal to -1, okay, and it passes through the y-axis, has a y-intercept at -3, okay, and it doesn't tell me what the other intercept is, but what it does tell me is that there is an axis of symmetry at x is equal to 1. Okay, so what we know about parabolas is that they are symmetrical in nature. So if I put a line right down here, then that is going to be the axis of symmetry. Okay, and this side is going to be reflected onto this side as well. Okay, so how are we going to use that? Okay, well, if this is the axis of symmetry at x is equal to 1, okay, and the intercept here is at x is equal to -1, well, what's the distance between these 2 points here? It's going to be a total distance of 2 units, okay, between -1 and 1. Okay, again, like I said, parabolas are symmetrical. So if this is 2 units, then this is also 2 units. Okay, so a total of 4 units after this x-intercept here is going to give me my other intercept. Okay, so there's a total of 4 units between the 2 intercepts. So 4 units after -1 is going to be the value 3. Okay, so that's how we find my other unknown intercept. Because once we have those 2 intercepts, then finding the equation of a quadratic is very easy. Okay, so we've done that. We found the intercepts. So let's find the equation of the quadratic now. So the first intercept is here at x is equal to x is equal to -1. So if I write that in my equation, it's going to look like as a factor of x plus 1. Now my next intercept is here at x is equal to 3. Okay, if I write that in my equation, then x minus 3 is going to be the factor. Okay, so we've written out the equation, but we still need to find this value a. Okay, so a is just a constant number. Okay, if we look at this graph, we can see that this graph passes through this y-intercept at y is equal to -3. Okay, so it passes through that point that is 0, -3. Okay, so if this graph passes through this point, that means if I substitute this point into this equation, then the equation should work. Okay, so that's what I'm going to do. So I'm going to substitute x is equal to 0 and y is equal to -3. Okay, so in your y here, put your -3, and in your other x's, I want you to put x is equal to 0. Okay, that's how we sub numbers in. So if we do that, this is what it will look like. Okay, I want you to simplify these little brackets and do that to find the value of a, which we can see a is equal to 1. Okay, well, what were we after? We're after the equation of the graph, okay, which was this. So I want you to write, replace a as 1 and rewrite the equation. Okay, then y equals to x plus 1, x minus 3 is going to be the equation of this parabola. Okay, so we used this axis of symmetry to find the other intercept. Okay, because once we know the intercepts, finding the equation of the parabola is very easy. So that was the first one. Now looking at this upside down parabola, so finding the equation of this graph. Okay, well let's take a look at what we do know. Okay, well we know that there's a y-intercept at x is equal to, there's a y-intercept at -7, and there's an x-intercept at 1. Okay, we don't know what the other x-intercept is, but we do know that the axis of symmetry is x is equal to 4. So the axis of symmetry of this parabola or this quadratic is at x is equal to 4. Then let's find the distance between here. Okay, so the first intercept and my axis of symmetry. So between 1 and 4 is going to be 3 units. Okay, now again, because this quadratic or this parabola is symmetrical in nature, this is 3 units, then this one must also be 3 units. Okay, so this intercept at x is equal to 1, 6 units later, we're going to have another intercept at 7. Okay, so now we have intercept here, then we can find the equation of my parabola, okay, of my quadratic. So the first one is the intercept x is equal to 1, okay, which we're going to write x minus 1 as a factor. Okay, now my next one is at here. X is equal to 7. Okay, so if x is equal to 7, then my factor is going to be x minus 7. So this is going to be my equation of my quadratic. Okay, however, we still need to do a bit of working to find the constant a, and then we're done. Okay, so to find that a, okay, well, we know this graph passes through this intercept, and also this intercept, okay, which is my y-intercept, which is also just a point, okay? It's just a point 0, -7, okay? So if this graph passes through this just point, okay, then if I substitute it into my equation, okay, it should work out. So let's try that. So put x is equal to 0 and y equals to -7 into my original equation. Okay, I want you to try. It should look like this. And if I simplify my little brackets, I want you to do that and to find the value of a, which we can see a is equal to -1. Okay, so to find the equation, I want you to rewrite the equation at the start with all the intercepts, okay, but put a is equal to -1. Okay, then this will be the equation of my quadratic. Okay, and we know it's right because it's upside down parabola and we have a negative equation here.